years. So I do hope that this webinar is not the only one that we can organize during this year and the next 3 years in the future. So we do hope that there are more and more collaboration activities that are conducting together between the ITB and BTHF. As you know that one of the mission of BTHF is to strengthen or to enforce the activities in the ITB campuses for education and as well as the research and community services. So I do hope that today's occasion benefiting all participants and will be a fruitful collaboration between ITB and BTHF. So I think that's all that I can say. So I thank you also for the time shared by the speaker today, and especially the speaker from the Netherlands, Professor Matisko. Yeah. So hopefully that the participant that attends this webinar has a new knowledge and as well as ideas to do whatever they can to attack the problem within the Citarum region. So hopefully this webinar has successfully conducted today, and please enjoy the afternoon and the morning by listening to the lecture about our discussion during today's occasion. Thank you very much, Pak Elko. I think that's all I can give you the
Okay, thank you very much, Pak Joko. I appreciate very much the cooperation we get from your side for the cooperation between ITB and BTHF, and thanks for your words. Now I would like to give the word to Bob Arthur Lambogia. We are very pleased that you're able to join also, because the subject is about the Citarum, and you've been very, very much involved in the Citarum. So very much welcome to our webinar, and please welcome your opening statements. Bob? Bob, can you hear us?
Sorry.
Yes.
Thank you.
Okay,
thank you for the invitation. To me, I feel happy to join this webinar. Pak Joko, selamat sore. Mr. Pus, Pak Pus, selamat sore. Bapak-bapak dan ibu-ibu sekalian, para mahasiswa ITB baik mungkin S1 sama yang jurusan spesialis yang hadir pada webinar ini. Memang undangan ini tiba-tiba ya, Mbak Fani. Tiba-tiba, dan kebetulan saya juga nantinya akan ada pertemuan nanti sebentar sesudah ini. Jadi sudah saya menyampaikan beberapa penyampaian dari saya. Mungkin saya mohon izin lanjut dengan rapat selanjutnya. Baik, berdasarkan undangan ini kami nantinya akan menyampaikan tentang bagaimana sistem pengendalian banjir yang ada di wilayah Sungai Citarum. Namun secara umum akan kami sampaikan prinsip-prinsip bagaimana caranya mengendalikan banjir. Lanjut aja, lanjut. Ini adalah lanjut dari pertama. Uh, perlu kita ketahui bersama bahwa penyebab banjir itu disebabkan oleh aktivitas manusia dan ada yang disebabkan oleh kondisi alam. Dalam paparan ini kita bisa melihat bahwa banjir itu terjadi karena kondisi alam, itu curah hujan yang tinggi atau terjadi air pasang atau high tide, di mana akibat daripada aktivitas manusia seperti membuang sampah sembarangan, kemudian melakukan eksploitasi terhadap air tanah menyebabkan terjadinya land subsidence. Selanjutnya ada juga permasalahan penyempitan sungai atau berkurangnya lebar sungai. Hal tersebut disebabkan oleh okupasi sepadan dan badan sungai. Kemudian adanya bangunan cross drain yang melintang di sungai. Selanjutnya juga banjir itu disebabkan oleh sedimentasi. Sedimentasi ini disebabkan penyebab daripada sedimentasi adalah karena catchment area yang kritis, yaitu terjadinya akibatnya menyebabkan terjadinya runoff meningkat. Kemudian ada juga terjadi longsoran di daerah hulu akibat kebanyakan lereng yang curam, kemudian erosi permukaan. Keadaan ini menyebabkan seperti kita lihat di dalam bulatan kuning itu bahwa di satu sisi kapasitas tampungan sungai menurun, namun di sisi lain itu debit air sungai meningkat. Ini adalah suatu kondisi yang kontradiktif, sehingga hal ini sering menyebabkan terjadi akumulasi air di badan-badan sungai dan menyebabkan banjir. Lanjut. Ini adalah ilustrasi akibat terjadinya urbanisasi pada daerah-daerah tangkapan air hujan, di mana pada kondisi ilustrasi pada gambar pertama, bahwa kita ilustrasikan ada infiltrasi dan ada runoff. Kita lihat ilustrasinya runoff-nya, kalau kondisi catchment area seperti ini, maka seandainya kita hitung runoff 10%, itu ada infiltrasi 50%. Maka sesudah catchment area ini terjadi proses urbanisasi, maka akan menyebabkan meningkatnya runoff dan menurunnya infiltrasi. Ini disebabkan akibat adanya perkembangan daripada kota yang menyebabkan limpasan air di permukaan atau runoff. Hal inilah yang menyebabkan bahwa suatu daerah yang biasanya tidak mengalami banjir, pada saat terjadi perubahan catchment area itu dapat menyebabkan banjir, sehingga orang bisa berkata dulu di sini tidak banjir dan sekarang ini kok sudah banjir. Hal ini disebabkan adalah dua kondisi ini, yaitu meningkatnya runoff coefficient dan menurunnya infiltrasi. Lanjut. Ini adalah strategi perencanaan pengendalian banjir yang kami lakukan. Di dalam suatu wilayah kita membagi-bagi, ada wilayah hulu, wilayah tengah, dan wilayah hilir. Di dalam suatu daerah aliran sungai, di mana daerah aliran sungai Citarum itu yang menjadi permasalahan paling penting adalah daerah bagian hulu. Daerah bagian hulu itu kita lihat bahwa di bagian hulu sungai Citarum itu catchment areanya sudah sangat memprihatinkan, sehingga perlu ada upaya-upaya untuk dilakukan perbaikan daerah tangkapan air. Kemudian di daerah tengah, strateginya adalah bagaimana kita memperlambat air masuk ke Sungai Citarum. Dalam hal ini di Sungai Citarum terdapat di daerah hulu ada kurang lebih 14 anak sungai. Bagaimana caranya agar supaya air-air yang ada dari anak-anak sungai ini dapat kita perlambat masuk ke Sungai Citarum, karena Sungai Citarum nantinya akan jadi seperti tampungan air dari 14 anak sungai itu, dan menyebabkan muka air daripada Sungai Citarum itu menurun. Nah, caranya adalah dengan kita melakukan pembangunan tampungan-tampungan air dalam bentuk apakah kita membentuk embung-embung atau kolam retensi atau long storage yang dapat kita bangun di daerah tersebut. Kemudian perlu juga ada pengendalian sedimen dengan cara membangun kantong-kantong sedimen atau kantong-kantong lumpur. Selanjutnya di daerah hilir, kita strateginya adalah bagaimana kita mempercepat aliran air ke muara, di mana caranya adalah dengan kita memperbesar kapasitas tampungan yang tadinya sudah mengecil, kita perbesar kembali, kemudian membangun sistem polder atau kolektor drain, pintu air, pemumpaan air di area genangan. Dan itu program ini sementara dikerjakan di wilayah Sungai Citarum, terutama di daerah Citarum Hulu. Kita lihat di sana sekarang ada pembangunan, beberapa pembangunan yang sudah selesai dan sementara dikerjakan. Seperti kita membangun kolam retensi di Cienteng, kemudian kita membangun cekdam di daerah hulu, kemudian kita menormalisasi beberapa sungai dan kita membangun floodway dan yang sudah selesai. Kemudian kita juga membangun terowongan Anjung, dan itu kemarin saya ke lokasi daerah tersebut untuk floodway Cisangkui itu sudah menjalankan fungsinya, sehingga kondisi tadinya air sungai Cisangkui dia terakumulasi di daerah muara di Sungai Citarum, bertemu juga dengan Sungai Cikapundung. Sekarang kita lihat kalau air Sungai Citarum tinggi, air malah balik masuk ke Sungai Cisangkui, sehingga Sungai Cisangkui itu menjalankan fungsinya seperti long storage. Tadinya dia mensuplai air yang cukup besar, sekarang malah air Sungai Citarum yang masuk ke Citarum. Hal itu sangat membantu untuk menurunkan elevasi daripada muka air yang berada di Sungai Citarum, terutama di wilayah Bale Endah dan Dayakolot. Lanjut. Ini adalah wilayah sungai yang ada di Jawa Barat. Kita mempunyai 6 wilayah sungai di wilayah Jawa Barat, dan wilayah sungai Citarum adalah yang kita tulis di kotak merah. Wilayah sungai ini memiliki 19 das. Di wilayah Sungai Citarum yang merupakan kewenangan Balai Wilayah Sungai Citarum itu memiliki 19 das, dan di situ ada banyak sekali sungai-sungai mulai dari hulu sampai di hilir. Lanjut. Di das Citarum atau di wilayah Sungai Citarum itu terdapat potensi air yang cukup besar, yaitu air sebetulnya potensi air Sungai Citarum ya kurang lebih ada 12 miliar kubik per tahun, namun yang dapat dimanfaatkan hanya 7,65 miliar per tahun dan terbuang ke laut 5,3 miliar per tahun. Untuk 7,65 miliar meter kubik per tahun itu sudah digunakan terutama untuk penyediaan air baku perkotaan lewat bendungan-bendungan yang ada, kemudian lewat intake yang dibangun untuk air baku, kemudian ada pembangkit listrik, kemudian penyediaan air irigasi untuk kedaulatan pangan, kemudian kegiatan perikanan dan kegiatan olahraga dan wisata. Kita tahu bersama bahwa di Sungai Citarum ada 3 buah waduk, yaitu Waduk Jatiluhur, Cirata, dan Saguling. Nah, hal ini, keberadaan 3 waduk ini sangat berguna terutama untuk pengendalian banjir di daerah hilir, sehingga di daerah hilir itu air dapat terkontrol melalui waduk-waduk ini. Selain itu di daerah hilir juga mungkin perlu ada penanganan waduk yang lain. Nantinya sementara dikerjakan adalah sementara difinalkan untuk desainnya adalah Waduk Cibeet, di mana Waduk Cibeet itu nantinya akan meredam banjir di daerah Bekasi dan daerah Karawang. Kita tahu bersama bahwa seperti yang saya katakan tadi bahwa das Citarum ada kurang lebih 19 buah yang tersebar di 12 kabupaten kota, di mana luas total wilayah Sungai Citarum adalah 11.300 kurang lebih 11.300 km persegi atau 32% dari luas Provinsi Jawa Barat. Sedangkan panjang daripada Sungai Citarum adalah 297 km. Lanjut. Saya ingin menyampaikan kepada peserta, terutama pada adik-adik mahasiswa dan peserta sekalian, bahwa inilah skema permasalahan yang terjadi sebetulnya di Sungai Citarum. Saya rasa ini bisa kita kembangkan dan menjadi sangat luas itu ilmunya, di mana permasalahan ini adalah dalam berbentuk pohon masalah, di mana yang menjadi persoalan sebetulnya adalah yang di bulat kuning, di bulatan kuning itu adalah kualitas air dan kuantitas air. Kemudian kontinuitas daripada ketersediaan air tersebut. Masalah kualitas air itu pertama menyangkut terjadinya pencemaran. Kita tahu bersama bahwa di Sungai Citarum sekarang sungainya sangat tercemar. Oleh sebab itu melalui Perpres 15 tahun 2019 kemarin keluar peraturan Presiden untuk penyelamatan, untuk percepatan pemulihan pencemaran di Sungai Citarum, sehingga ada namanya program Citarum Harum. Selanjutnya itu kalau kita lihat bahwa pencemaran yang terjadi di Sungai Citarum itu disebabkan oleh dua, yaitu limbah dan sampah. Limbah itu berasal dari pabrik, kemudian berasal dari domestik, kemudian peternakan dan pertanian. Sedangkan sampah itu adalah produk daripada masyarakat setempat dan membuang sampah langsung ke sungai. Nah, hal ini yang menyebabkan Sungai Citarum itu mengalami pencemaran yang luar biasa. Perlu kami informasikan bahwa yang paling mencemari adalah limbah, di mana sebetulnya limbah yang mencemari paling banyak adalah limbah domestik. Limbah domestik itu kurang lebih 70% dari total limbah yang masuk ke Sungai Citarum. Jadi hal itu perlu menjadi pemikiran daripada adik-adik mahasiswa sekalian dan peserta, agar supaya kita memfokus ke salah satunya adalah masalah limbah di sana. Kemudian sampah juga tetap berlangsung. Sekarang ada TNI di sana. Untuk membantu, tugas TNI adalah membantu membuat masyarakat menjadi sadar, menjadi mengerti bahwa sungai itu bukan tempat membuang sampah. Selain itu, kurangnya fasilitas persampahan yang ada di daerah sekitar Sungai Citarum, sehingga masyarakat mencari tempat yang paling gampang membuang sampah, yaitu di tempat pembuangan sampah yang besar sekali itu, yaitu Sungai Citarum. Anggapannya seperti itu. Kemudian masalah limbah, selain pengelolaan limbah yang belum optimal karena sistem pengelolaan drainase dari pemukiman itu masih semuanya itu bermuara ke Sungai Citarum. Juga ada masalah ipal-ipal yang belum dioptimalkan, belum difungsikan dengan baik. Dari secara kasat mata ipalnya ada, tapi dalam operasionalnya hidup mati pengoperasian daripada ipal tersebut. Kemudian selain itu juga belum ada fasilitas penanganan limbah yang terpadu. Selanjutnya masalah banjir. Banjir selain disebabkan juga oleh sampah, juga oleh sedimentasi dan land subsidence. Untuk masalah sedimentasi itu disebabkan oleh erosi permukaan tanah dan longsoran. Kita tahu bersama bahwa daerah hulu daripada Sungai Citarum itu sudah sangat kritis. Kalau nggak salah ada kurang lebih 43% itu mengalami kekritisan, sehingga seperti yang saya ilustrasikan tadi, pada saat terjadi hujan maka run off akan besar infiltrasi kecil sehingga menyebabkan lahan terkikis dan semuanya sedimen-sedimen yang tanah yang terkikis itu bermuara di Sungai Citarum. Selain itu juga masalah metode bercocok tanam yang kurang tepat sehingga menyebabkan terjadi erosi permukaan. Selain itu juga masih masih kurang itu bangunan-bangunan penangkap sedimen sehingga sedimen belum bisa terkendali dengan baik. Selanjutnya masalah land subsidence itu disebabkan oleh eksploitasi air tanah yang berlebih. Hal ini disebabkan karena terjadinya defisit air baku permukaan. Dari perhitungan kebutuhan air baku dan ketersediaan air baku di daerah metropolitan Bandung sebetulnya perhitungan tahun 2015 itu kekurangan 8,5 meter kubik per detik. Harusnya dalam teori bahwa apabila kekurangan air baku itu masyarakat itu kekurangan air baku itu dia akan pindah, tapi ternyata sudah minus 8,5 meter kubik per detik, itu penduduk makin lama makin bertambah. Hal ini karena apa? Karena mereka masih masih mendapatkan air baku. Nah, sumber air baku itu dari mana? Ya tentunya bukan dari air permukaan, ambilnya dari air tanah. Hal itu yang menyebabkan masyarakat mengeksploitasi air tanah yang menyebabkan terjadinya penurunan tanah atau land subsidence yang kita tahu bersama dia bisa sampai di daerah Dayakolot 14 cm per tahun dia turun. Selanjutnya berkurangnya lebar sungai disebabkan oleh okupasi bantaran bahkan sempadan sungai. Kalau kita lihat bersama bahwa kita tahu bersama bahwa sungai-sungai terutama di Kota Bandung itu semuanya sudah mengecil. Tidak ada satupun sungai yang membesar. Artinya telah terjadi okupasi. Hal ini disebabkan karena mungkin kita perlu kajian-kajian perizinan yang harus lebih optimal lagi agar supaya perizinan mendirikan bangunan di daerah bantaran ataupun di daerah sempadan itu dapat kita cegah. Kemudian mungkin perlu ada penertiban bangunan-bangunan yang berada di daerah bantaran atau sempadan yang belum maksimal. Dan yang terpenting lagi bahwa kenapa orang bisa masuk kadang-kadang sungai itu tadinya sungai sekarang sudah jadi jalan atau sudah jadi bangunan rumah. Hal ini disebabkan karena status daripada kepemilikan bantaran dan badan sungai itu masih dalam status kekayaan negara, belum menjadi aset negara sehingga masyarakat hal itu menyebabkan status daripada badan sungai itu belum jelas, sehingga terjadilah okupasi sama seperti di daerah pantai. Saya kira masalah-masalah itu terjadi, namun pada saat ini pemerintah lewat Kementerian ATR BPN sementara melakukan upaya-upaya agar supaya hal-hal seperti ini dapat dicegah. Lanjut. Ini adalah kondisi hasil penelitian dari sebuah konsultan yang kira-kira permasalahan dari hulu ke hilir seperti ini. Seperti yang saya jelaskan dalam skema tadi bahwa data-data mengenai apa yang saya tulis sebelumnya itu ada di sini. Kita lihat di sini contoh ada kurang lebih 280 ton limbah dari 1.500 industri. Kemudian ada 8,2 juta ton per tahun sedimen yang masuk ke Sungai Citarum. Itu di daerah hulu dan seterusnya sampai di daerah hilir. Saya kira itu persoalan-persoalan yang perlu kita sikapi bersama. Kemudian di dalam upaya-upaya penanganannya kami dari Kementerian PU sudah melakukan berbagai upaya untuk pengendalian banjir di daerah daerah cekungan Bandung di Sungai Citarum dan anak-anak sungainya, dan mungkin adik-adik mahasiswa sebentar itu kalau mau ada kunjungan lapangan dapat melihat sistem pengendalian banjir yang ada di Citarum, di mana bagi kami bahwa sistem pengendalian banjir yang ada di Citarum itu sudah sangat lengkap, karena itu terkombinasi, terencana mulai dari hulu sampai di hilir. Untuk proses pembelajarannya di sana sudah ada macam-macam bangunan-bangunan pengendali banjir ada di sana semua, sehingga saya sering mengatakan bahwa laboratorium lapangan untuk ilmu pengendalian banjir itu kita belajar di Citarum, mulai dari cek dam, kemudian floodway, normalisasi kolam retensi, embung, kemudian ada terowongan atau tunnel. Itu dalam rangka pengendalian banjir itu semua ada di Bandung, dan hal itu sangat baik bagi adik-adik mahasiswa untuk belajar melakukan studi lapangan, agar supaya selain adik-adik itu belajar mengenai teori di kampus, perlu diimplementasikan atau diaplikasikan di lapangan, dan itu bisa kita bisa lihat di pengendalian banjir di Sungai Citarum. Saya kira itu yang dapat kami sampaikan sebagai pembuka daripada acara ini. Terima kasih atas waktu yang diberikan, dan mohon izin sesudah ini saya ada meeting yang lain. Saya akan mohon izin untuk meninggalkan grup ini, meninggalkan webinar ini. Terima kasih atas waktu yang diberikan. Selamat sore.
Terima kasih Pak Bu.
Terima kasih banyak Pak Bob. Thanks so very much for this comprehensive overview of the problems. We appreciate very much your contribution. I would now like to ask Professor Citarum to make some opening statements before going to the other part of the program. Professor Citarum.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everybody in depth. So it is honor for us to arrange this event. As all we know that we have problem in Citarum, just the neighbor of ITB. What the same if we could not contribute to this problem solution of Citarum, that one of these ITB expertise in this case. So we are happy to have a partner from DAF and Delta Res. I think we are like a brotherhood. So you contribute a lot to the development of ITB since the beginnings. And of course, it is our culture, both of us, to sustain the cooperation in developing ITB and contribute to the national development, in this case for Citarum. I think we are welcoming your contribution here, and also Pak Joko Hadi, thank you very much to help us arrange this matter. Thank you. Good webinar in this case.
Okay, thank you very much, Professor Citarum. We appreciate also your cooperation for BTHF involvement in ITB in general, but in particular from our background in the water field where you're teaching. So we will now have 3 lectures, but I also want to mention that we will have a short quiz with a prize that the participants can win. And we will conclude with a competition that will be at the end. But now we start with the lectures. But before I do that, I will mention a little bit about BTHF. And BTHF is the Bandung Technische Hogeschoolfonds. You see in the in the Dutch language that I'm using, that it is already a very old foundation. It was established in 1926 with the aim to support education and research at the ITB, but it still was called Technische Hogeschool at that time, and stimulate the cooperation between Indonesian and Netherlands institutes. And now the main activities that we do, I'm not going to tell all the details, but the main activities is the yearly Ganesha Prize for the best ITB bachelor graduate student that we are supporting as BTHF. And we provide the grants for research and exchange fellowships and organize this kind of activities. Of course, today we talk about the water field, but let's be clear, BTHF is not only about water, it is also about pharmacy, about aeronautical engineering. So this is about water, but for example, the yearly Ganesha Prize goes to many other departments. So with that short introduction, I would like to give the word to Pa Hadi to start the first lecture. Pa Hadi.
Thank you, Pa Elko. Allow me to share my presentation. Okay, I will arrange my slide first. Okay, good afternoon and good morning, ladies and gentlemen from Indonesia and from Netherlands. I would like to share my my point of view regarding the issues and researchers in Upper Citarum River Basin. As you might know that in ITB we have a research group called Water Resource Engineering Research Group that dealing with the water management. Yeah, and since I focus on the Upper Citarum, before Pa Bob mentioned about whole Citarum, but I will focus on small part of Citarum, which is the upper part, which is upper part from Saguling Reservoir. Saguling Reservoir, we have about 700 kilometers square of area, and it lies on the plateaus. We have about 9 million inhabitants, 8.6 million now. I'm sorry, last year, and we have about 2.1 billion of runoff per annum. Yeah. Our evapotranspiration potential about 3.3 millimeter. And based on this figure, I think we have very optimistic about the water availability. Yeah. Based on this runoff, we have enough water to fulfill this population. Yeah. Based on the standard, this kind of figures only requires about 500 million cubic meter of water for domestic purpose. We have 2.1 billion, so we're a little bit optimistic. Yeah. However, there's some concern about this optimistic assessment, which I will explain later on. Yeah. So regarding issues, Pa Bob already mentioned about the problem in Citarum, but I will make some short problem statement in the technical point of view. I think we can have about 5 problems in Citarum, especially in Upper Citarum. The first one is poor water quality. Yeah. And in Upper Citarum, we don't have city or local sewer system. And this alone cause so much problem in our river system. And in industries, in the agricultures, in the farming, also we don't have enough wastewater treatment plant. So this adds more problem. And besides that, we have also solid waste problem, and we don't have any sufficient program for the sustainable agriculture. So critical land is appear everywhere and causing some erosion that contribute to the sedimentation in Citarum. Yeah, and flooding. I think Pak Bob is already mentioned many about this one, but I think the waste, the solid waste and sediment also cause additional problem for our river system, because if we design on the certain design capacity, then it will be disrupted by no time. So we have to invest more on the operation and maintenance, yeah, to maintain the capacity. And this also worsened by substandard design parameter. Yeah. So I will catch that later. And under resource flood control and management, I think we already made some good progress in this issues flood control. We have a new tunnel. We have a new basin, yeah, in southern part of Bandung, but we still have flooding problem, yeah, that still need to be addressed and put some money on these issues, yeah. And the third is excessive groundwater extraction and land subsidence, and this is due to the low dependable flow. We have a very big runoff, but we have a very low dependable flow, especially during dry season. So this encourage people to extract water from ground, including industries. And this worsened by low capacity and performance of distribution system. So our pipe network is somehow less coverage. So this also encourage people to extract water from groundwater. Yeah. And later on is insufficient reservoir capacity. I think the major capacity in Upper Citarum is Situ Cilenca, about 10 million cubic meter, and it's already very old. Yeah, I think it's around maybe beginning of 20th century. Yeah. And the draft and under utilized renewable energy potential is other problem statement, I think. So to address the water quality, the government is already placed some big project called Citarum Harum, and it planned until 2025. It's very ambitious project, and it requires almost 16 trillion rupiahs. Yeah, but this during pandemic, I think the progress is not as expected. Yeah, it has very structural project, which have 3 policies, 5 strategies, and 13 programs. It's all odd number, yeah? And all programs is cross-cutting issues, not built only by the Ministry of Public Works, but dealt with all ministry in Indonesia. Yeah. But I will highlight only 3 cross-cutting issues, which is the critical area, solid waste treatment, and water management. Because in these three cross-cutting issue, we have one sector is very dominant, which is Ministry of Public Works. Yeah. So, so I think we have good plan, but the question is how we implement this plan. Yeah. And the outcome is to address the pollution index. Yeah, pollution index. With if we categorize the water, we have target until level 2 of water quality. Yeah, this is quite ambitious target. Yeah, but we have to try to achieve that target. And for addressing one issue, which is the critical land that contribute to the sedimentation, we only progress about 6.5% right now. Yeah, and as you can see that we have many agencies here, that dealing with this program. Yeah, and I think we have a pessimistic assessment for this progress. However, we still have some hope if the pandemic is already disappear. Yeah, hopefully. And this is some snapshot of the progress. Yeah. So this is only a snapshot because the cleaning of the water body is already underway, and we have see some progress. But we all know that the source of this pollutant is in the upstream. So not only dealing with the cleaning, but we also have to address the upstream sources. Yeah. Okay. And regarding flooding, in Citarum, we can see that the higher extreme frequency is expected. During 70s and 80s, if we design the canal or the flood controls infrastructure by 10 years return period, now becoming 5 years return periods in 90s and 20s, yeah, and 2000, I'm sorry. And it led us to the outdated construction design parameter. So our old structure is already outdated, yeah, because we don't have capacity as planned, yeah. So this also give more problem to our infrastructures, yeah. So, and this is the figures from Irwan et al. 2015, our college from Faculty of Earth Science, that the groundwater extraction and land subsidence is quite severe in this area. Yeah, it can exceed 1 centimeter per year. In one area, it can reach 2 meters from between 11 years span. Yeah. So it's quite a big problem because it will cause additional problem to flooding. Yeah, because the land tends to decrease and the flooding is increased. Yeah, and beside of the land subsidence, also the groundwater table is also decreasing. 1 point reach about 1.79 meter per annum. It's very severe because, like I said, that our dependable flow is very low during dry season. Yeah. However, not only the groundwater extraction that causes land subsidence, but they also have some evidence that natural compaction is also occurred in this area. So this also additional problem for flooding. Yeah. So for the dependable flow, I think we can say that in the past we have lesser water than now. Yeah, during high flow and during low flow. And during high flow, we are expecting more discharge, and also during low flow. However, during low flow, we only have about 10 cubic meter per second of water for 90% exceedance probability, which is barely enough for domestic purposes. So if we have about 8.6 million, we need about 5 cubic meter per second of water. And it's based on these figures that we can expect that about 20% will not achieve that figures. Yeah. 20% will not exceed that figures. So people will tend to draw water from groundwater, and it also has some condition that our pipe network is only 30%, yeah, of all area, and our loss is about 40%. So if we have the supply water of 15 cumex, the losses is 40%. So we need more supply in our intakes, yeah, because of this low dependable flow. So this is the figures that need to be evaluate and become our baseline before we are setting the effort to dealing with the problems. Yeah. And for the second part of my lectures, I will share some snapshot of research in Upper Citarum River Basin. So I think most of this research is done by our students. So if the participants is students, so you will make one of these, yeah. So I will share a few of or several of this research to you, yeah. So on 2016 in Bandung area, because we see that we have low dependable flow, so the strategy is to increase the reservoir. Yeah. We don't have enough resource for building a large reservoir, and we don't have any site to make one. So we can encourage people at home to build their own reservoir. Yeah. So based on this system, we expected that if we have 2 meter cubic of reservoir at home, then if this home has about 4%, then from our rainfall condition in Bandung area, we can have about 65% of needs that filled by rainwater. So if our system is made from this rainwater, for example, for flushing, we are just connected from the rainwater by pipe to the underground tank. Then we can fulfill that amount of portion. Yeah. Then it will decrease the tension to our supply system. Yeah. And however, we also acknowledge that using this particular system, we also have to deal with the quality of rainwater. In Bandung, we have a little bit acidic, so we need to address about the water quality treatment before we use this system in the policy level. Yeah. Okay. Yeah. And the second research, I think, from Mr. Asep 2020 is from MPSDA. Yeah. So Pak Asep is dealing with the ununiform rainfall. As you know, during flood in Citarum, in Upper Citarum River Basin, it's not only uniform rainfall that causing flood, but non-uniform rainfall is also causing flood. And our rain gauge sometimes cannot cover those rain system. So, and this ununiform rainfall also causing the time peak that vary from time to time. So we need to have some good approach to estimate the discharge. Then we propose that some parameters need to be included in the time lag calculation. We call it rainfall moment. Basically, the distance between the outlet and the rainfall storm cell. Yeah. So based on this, we can modify the time to peak of the a hydrograph. Then we can increase the performance of the hydrograph estimation that incorporate the rainfall that not uniform. So based on this, we can improve the estimation, yeah, of hydrograph in the term of the time to peak and in the term of the magnitude of the peak discharge. Then we can have good estimation if we want to set the flood early warning system based on the simple approach. Then we can have this kind of approach, yeah, that incorporate the time to peak, yeah. And then the other research is done by master students from civil engineering that also dealing with the ununiform of rainfall. But we are using the reanalysis rainfall by global data, and we compare it with the rain gauge network that we have from BMKGs, yeah, BMKG. And we see that there's some similarity between the rain gauge network and the reanalysis precipitation, but we need to adjust the reanalysis precipitation or global precipitation data with our ground data. Yeah. And then we can somehow use the data for other purpose. Yeah, for other purpose. And we believe that with proper treatment, analysis precipitation data or global data can be used or very useful for relative type data or global purpose. We cannot use it for the design purpose, but for the data that are relative or the global, we can use it. Okay? And for example, in this research, we can develop the IRF for whole West Java with low degree of uncertainty. Yeah. And we can compare it with the standard that have in our SNE, standard national, and we can have comparison with the US standard. But we have include our own our own characteristic in Indonesia. So we can use it for other part in Indonesia, because we know in Indonesia we have different climate characteristic and different weather system. Yeah. So this is done by Mr. Asferiza, 2019. Yeah. And I think this one is from students from Delft by Honi et al. Yeah. So 2019, she and her college come here and did study in Cikapunung River, one of the tributaries of Citarum River, Cikapunung River. And they found that some truss rack and they quantified that the truss rack is contribute to the rise of water elevation in the quantitative way. Yeah, in the quantitative way. So we can expect that if we build a truss rack in the river, it will give us more problem regarding the flood, yeah, compared to the problem of the waste. Yeah. So based on this finding, I think we can assess the placement of the truss rack in our infrastructures, yeah, especially during flood events. Yeah. And the last is I think Mrs. Olivia, 2019. Yeah. So she also did studies in Upper Citarum. Basically, she developed an algorithm to find the potential, the hydropower potential. The algorithm is automatic, based on DEM, digital elevation model, and it incorporates the river diversion. So if we input the DEM and the data of the dependable flow for each river pixels, then we can extract which location that has the biggest potential. And then we can filter it based on some feasibility criteria. Yeah. And we can compare it with the existing hydropower. And her estimation is quite good, because some of the existing hydropower can be estimated based on her algorithm. Yeah. And I think this algorithm is innovative way to find a renewable energy potential that can be applied in other part in Indonesia. As you know that we have about 99% of electrification ratio. So it means that 1% of our people don't have access to electricity, and basically they are mostly in the mountainous area. So based on this, we can estimate which area that can be potential to build the hydropower. Yeah. So I think there's several of the research that I would like to share with you all participants and colleagues from Netherlands. And I hope this will be useful for you all. Thank you for your kind attention.
Thank you very much, Pahari, for this impressive overview of the research that are already carried out. And I see a lot of nice opportunities for cooperation in this field. By the way, if there are questions, please, all participants can use a chat box to ask questions, and we will try to pick them up after and during the Q&A session later. Can I now ask Professor Matthijs Kok to give his presentation? Matthijs, can you take over?
Yes, I can. Thank you very much, Pak Al Ilko. Let me hope to share the screen. I hope you can see my screen now.
Yes.
Well, good afternoon, everybody. I hope you are doing well. As you can see, my presentation is from my home in the Netherlands, and that's because the university is almost closed. Well, it's open, but we do not have a lot of students. We also work at home, and also myself, and that's because of the COVID crisis, and I hope this will end very soon. My second remark is that my presentation is not special about the Citarum River, but it's more in general. So I will present you some new approaches to flood risk management. I'm a professor of flood risk in the Delft University of Technology. And of course, this is a very broad topic, but I want to present you some new approaches which can be seen in flood risk management. This is my content of the presentation. I will give you some general background and also some examples of flood risk reductions, which can be seen everywhere in the world, and also I think also it can be applied to Indonesia. What we see in general about floods is that we see worldwide increasing damages of floods. And that's not only because of climate change. I think it has less to do with climate change, but it has more to do with the number of people which live in floodplains, in potential flooding areas, and also in delta regions. We see a lot of economic growth, and I think economic growth is a good thing because it gives more wealth to people, but also it has a negative side if the factories and the houses are in vulnerable areas. And my basic concern, because I'm a professor of risk, is what to do with the risk. Do you accept it? And of course, risk zero is almost impossible. So you have to accept some level of risk, but what kind of level do we take? And if you don't accept it, you have to take action. And one possible approach, which I teach also to my students, is that we follow the risk approach. So what is then the risk approach? Basically, it has I mean, you see the risk approach everywhere, all over the economy, in many sectors. And also flood risk follows the classical risk approach, that first we have to assess the flooding probabilities. And that's mainly the return periods of discharges, of water levels. But of course, if you have flood defenses, you also have to take into account that flood defenses will fail given some certain discharge. So that's a combination of what we call the hydraulic load, the discharges, water levels, waves, and the strength of flood defenses if there are flood defenses. And also if there are reservoirs, you also have to take that into account. Well, the next step is the assessment of the consequences. That's loss of life, economic damage. It can be many things. And if there is no damage, you almost have no problem. Well, the third step is to see what kind of risk is there in the area, and what kind of measures you can take to reduce the risk. So you have to assess the impact of these measures on the risk level, but also on other impacts of those measures. It can be ecological impacts. Often it will cost a lot of money, and you don't have often so much budget to take them all. So we have to set priorities. And that's, of course, the typical decision level, what measures to take, accept the risk level, or reduce the risk. Well, and of course, one of the main important questions is, of course, what is acceptable and for who is it acceptable? And in my approach, in the risk approach, it always depends on the consequences of the flood. So because if there are few consequences, you can accept the risk, but if there are many damages, you can say, well, we have to reduce the risk. It also depends on the policy. Some argue that we have to live with floods, and I think we do. We have to live with floods, but we can also take measures to reduce, to prevent floods, and we can do that as much as possible, or we can do that to a certain extent, because it also has a price. Well, in the Netherlands, we have the approach, and we still have the approach that we prevent floods as much as possible. And that's also because of the high consequences. And you may know that a part of the Netherlands is below sea level, and next to that also another part is subject of river floods. But there are many ways, of course, to reduce the floods, the risk of flooding, because there are many ways to do so. And I will give you some, not an overview, because that's quite impossible in 15 minutes. But what I can do is to give you some clues about ways to reduce the risk. And of course, there are many more ways to do so. And it also has to fit to the area. So I want to have some in this presentation. I want to show you the room for the river approach, as we have followed this in the Netherlands. I also will tell you about the flood defenses, the way we cope with that, and of course they are very traditional. What quite new is that we have approaches which we call building with nature, so that we use nature also to reduce the flood risk. And the final thing is that we also use apps to get people more aware of where floods can happen. Well, the first thing is a room for the river. Here you see some overview of what is meant with room for the river. But basically, it says that that if you have a floodplain with maybe possible flood defenses, you can increase the area of the river, and where you can relocate dikes. You can make side channels, you can lower the level of the floodplain, also the water levels will go down then. You can build what we call a green dike, so an extra side channel. You can reduce, if there are groins, the height of the groins. You can reduce obstacles. So there are many ways to get more, to have more room for the river. And here are some figures about the impact of a large room for the river program. And well, maybe it's not, these are a lot of figures, of course, but you see there's a lot of ground displacement. And also there are, in the Netherlands, we removed 200 houses
to have more space, to have more room for the river. So it also costs a price for people who are living there. And that's important. But of course, they are compensated by the government, but still it is a high price to do so. Well, then the next slide is about flood defenses. Well, this is not common in the Netherlands. I think it's not common everywhere, but what can be done is that you build flood defenses of glass. And the advantage is that still people have still the view over the river, but still you are protected. But of course, the glass has to be, the strength of the glass should be enough. And what we did last year in the Delft University, we made some tests about the strength of glass to have these elements part of a flood defense system in the Netherlands. But of course, this is quite exceptional. What is more traditional is to build also sheet piles in dikes. So you have an earthen dike, but also you put an element of a sheet pile in it. And traditionally, what is being done is that the strength of the flood defenses was calculated without the soil of the dike. And what has been done a few years ago, and a PhD is now being a thesis is now being written about this experiment. Is what about the additional strength of soil of a sheet pile in a dike, and these are very big tests. So this is a real life test, and you see So I think these sheet piles are more than 4 or 5 meters above the soil. So this is a very huge test, and also, of course, very costly. But I think it's worth the money because you get a lot of new knowledge of these tests. Well, and another approach is building safety with nature. This is from a thesis, PhD thesis last year of Vincent Fuik. So here you see a coastal area, and what can be done is that the floodplain, the area. So this is the dike, the green dike. So this is the sea, and of course there is a tide which goes up and down. And what you can do is that the vegetation in this area before the dike reduces the waves and the flood levels. So and the question is it how much does it reduce, and how and is it stable enough? Because if there is a storm and the vegetation is all gone, you don't have any reduction anymore. So this has been thoroughly investigated, and the good news is, well, there is some. And it reduces the flood waves, but of course, it doesn't mean you don't have to build dikes anymore. You still need the dike to prevent, but it can be less higher than traditional. Well, one of the funny things I want to have in this presentation is an app of the Dutch government, and the question is, if I live in a place in the Netherlands, so how high can the water come if there is some failure of a flood defense? And well, to show you the application, if I were sitting presenting this in a room, I would ask you, well, can the Rijksmuseum in Amsterdam, so this is a picture of it, can it be flooded or not? Well, if you ask yourself this question, it could be, but maybe not. Then you go to the app and you fill in the postcode, the postal code of this location, and then you will find the answer. And well, it's in Amsterdam, and you think, well, maybe Amsterdam is below sea level. Well, maybe, but maybe not. So the answer is that so this is you see the house on the line. You see that with the models we are using now, it cannot be flooded, and the reason is that well, parts of Amsterdam are below sea level, but the center of Amsterdam is around sea level. So if there is a flood, the more deeper areas will be flooded first, and the center of Amsterdam is not flooded. So it's the answer to the question is that the Rijksmuseum in Amsterdam cannot be flooded if we look at the current situation. And of course, the big question is, of course, if there is climate change, will that still be the case? Well, to give you another example, I work also in a company which is in the beautiful town of Lelystad, named after the Dutch Minister of Public Works, Mr. Lely. Well, and if you see from that office, well, it can be flooded, and the water depth can be 3.5 meters. Of course, well, so that the ground floor will be flooded, but also the first floor. But we also have a second floor, so we can still work at the second floor. But that's, of course, a joke, because if it's all flooded, you cannot access the building anymore. But it gives an impression of what the impact of a flood can be. And that, of course, raises also public awareness, which is also, I think, quite important. Well, then one slide about the Citarum River. I'm not special in this, and you heard a lot about this. So I think you know, you have heard in previous lecture much more than I can tell. But of course there are some water quality issues, but there are also flooding issues, and I think it's very worthwhile to strengthen the relation between Delft and you to investigate all these issues. Well, then my concluding remarks, because I think floods will be a challenging issue also in the future, and that's because of climate change. We heard a lot about it. We also hear a lot of fake news about climate change, but it does happen, it will happen. The only question is when and how much. And well, that's a very important question. And also, I think we see a tendency also in the Netherlands that people want to live in areas which are quite vulnerable for floods. So that's the western part of the Netherlands, in Amsterdam, in Rotterdam, and in Delft, and in The Hague. People really want to live there, and more the eastern part, which is relatively high. Well, it's not that popular. And so huge economic losses can happen, also loss of life. But I mean, the good news, it can be reduced by taking appropriate measures. Pak Eelco, this was my presentation.
Thank you, Matthijs, for this nice overview of the risk approach that we in the Netherlands indeed follow. And yeah, maybe some of the things that you mentioned gives a nice inspiration. For example, the nature-based solutions that are up. That can also be used to address the problems in Indonesia. I know, of course, the mangroves in the north coast of Java is also being applied, but the inspiration maybe also for the competition that we'll explain at the last part of this webinar. So thanks again, Matthijs. Again, I want to remind all the participants that if you have specific questions, then please put them in the chat box, and we will pick them up later. We now move to water quality. I see also already Ibu Irawandani in the screen, and she will give, on behalf of Deltares, where she is working, a presentation about the water quality management tools that Deltares has been applying. Ibu Irawandani, you're the floor.
Yeah, thank you, Pak Eelco Van Beek, for this opportunity. Can you hear my voice clearly?
Yes, we can hear it, and we see your screen. Thank you. Okay,
yeah. First of all, thank you also for BTHF for inviting me in this very interesting occasions. So my name is Irawardani, and I've been working in Deltares since 2018, and I have some work experience regarding water quality model development, especially for Citarum River basins. So within this opportunity, I will give a presentations about the topic of water quality model as the new approach to assist water quality management tools. So this is the content of my presentations. First, I would like to emphasize the emerging needs of water quality model. So how we perceive the water quality problems, we have a change of paradigm or shift of paradigm between the old paradigm and the new paradigm. So in the old paradigm, how we perceive the water quality problems such as eutrophications, domestic pollutions, industrial pollutions, we usually only use sampling and laboratory tests to determine the water quality parameter, if it's qualified or not qualified, based on the certain guidelines, if it's above the threshold value or under the threshold value. And sometimes the water quality experts also use statistical analysis to help define the hotspot or the safe spot based on their sampling and laboratory test result. And based on those measurements, usually the decision makers or the water managers arrange the water quality measures action. For example, if they think that the parameters related to the livestock management is the problem, they might want to increase the number of biogas productions. Or if they think that the domestic problem become one of the most important parameter, they want to increase the connection to the septic tank. And also if they have, for example, the most high parameter for the industrial pollution, they might want to increase the efficiency of wastewater treatment plant. But for the new paradigm, how we perceive the water quality problem, we see the water quality problem becoming more and more complicated. And there's a lot of emerging pollutants that we still don't know how to assess it. And we're also facing a lot of problem like massive population growth, the land use cover change, land cover change, and also climate change issue becoming more serious and getting more concerned. And also the massive economic growth also leading us to more pollution to the river. And so we as a scientist or as a decision makers, maybe not only think about the current situations, but also think about what is the next situations for the 10 or 100 years, and will be the river quality status still be good for our next generations. And to answer that questions, the sampling and laboratory test is not enough. So that's why the water quality model is important and is needed. So with water quality model, we can quantify or we can calculate the number of pollutants based on their source, how they can enter the river body, and we can simulate the amount of load or the amount of pollutants within certain time period, like 1 year, 10 years, or 100 years. And then the function of the sampling and laboratory tests also can be used for validate or calibrate our model output. And sometimes we also combine these tools with health risk assessment to get to know more about the effect of the deterioration of water quality for the health risk of the populations. And some of the decision makers or manager also can use these tools to determine their water quality measures, and also combine it with some of the climate change scenario for more than 10 or 100 years time span. And also they can also combine it with management option scenario. If they only have, for example, only limited budget, but they have a lot of problems and a lot of options for their management. So it will be really useful for the management option scenario. And then I will discuss more about the water quality tools. As I told you before about the sampling and laboratory analysis, I would say that to do the sampling and laboratory analysis for all pollutants is nearly impossible because it will be really costly, it will be expensive, and we still lack of facilities and a lack of resource to do that. And for some of the parameters, we still lack of technology development. For example, in Citarum River itself, as I know, we have 3 institutions that doing the measurements on water quality. There are PGT2 or Perum Jasa Tirta 2, West Java ITB or Dinas Lingkungan Hidup Jawa Barat, and Pusair, or we are now call it as Direktorat Bina Teknik SDA, also under the Ministry of Public Works. And those 3 institutions, if you accumulate, they only measures no more than 15 water quality parameters. But in fact, in reality, we have much more than that. That's for the sampling and laboratory analysis. And for water quality model, we also have a lot of options to do the modeling for water quality. And some of the water quality model also, the development from the hydrology model itself. And some of you may be already familiar with HECRAS or SWOT, maybe soil and water assessment tool. And there's also IMOD used for a groundwater quality model. And we, Deltares, also have several options to do the water quality model. We have Sobek Dawak, Delft 3D Dawak, and the emissions. I will tell you more about this in the later presentation. And also, we can do also remote sensing water quality model. For Citarum River Basin, LAPAN, or Lembaga Antariksa dan Penerbangan Nasional, already has remote sensing water quality model for 3 reservoirs in Citarum River Basin, for Saguling, Jatiluhur, and Cirata Reservoir, but only for physical parameters. And to do these water quality models, it's actually we still facing a lot of challenge because, as I said before, there are many parameters to be modeled, and to model a lot of parameters for water quality, it really takes time to run. And the model validations is quite difficult because we only have limited data available to compare to our model output. And then I will move to the prioritizations of pollutants for Citarum River Basin. So the blue box, the indicators that we already know. Some of you are already familiar maybe with like dissolved oxygen, BOD, inorganic and also organic micropollutants, heavy metals, and also bacterial contaminants like fecal coli, coliform, and Escherichia coli, and also even the physical parameters like pH, like regime, and also temperature. And how we decided water quality indicators in our model, usually, if you see the green box, usually we will think about the water quality effect first. So if we think that the most impactful in our for example, is the swimming or the drinking water, we only maybe we can only try to model bacteria as a water quality one, but if we see the effect, we can only model the nutrients or the eutrophications in our model. And also for the ecosystem health effect, we can only model the sediment as a water quality indicator. We can also model more than 5 parameters, but as I told you before, it can take more times to run and it will be really complicated. Besides all the common pollutants, we also have a lot of new emerging pollutants. For example, the pharmaceutical pollutants, especially we are now in the COVID pandemic time, we still don't know how much pharmaceutical compounds or maybe antibiotics residues that enter our river system from the hospital wastewater treatment plant. And there's also a lot of healthcare products and endocrine disrupting compounds that contains a lot of dangerous contaminants in our river. And there's also microplastic and also persistent organic pollutants which are really hard to be degraded in our environment. And if you count these emerging pollutants, it can be more than 200 pollutants. And these pollutants is still a lack of research, lack of technology development to assess. It's really limited in some countries, including in Indonesia. So how we do the prioritization of water quality parameters in Citarum River. So I found one interesting study from West Java EPA staff. He did the PhD in one of the university in Australia, and he do the prioritization of water quality parameters for Citarum River Basin. So what he did is he classified the 7 grouping of parameters for water quality parameters. So the grouping of parameters includes physical parameters, oxygen depletion, nutrients, organics, ions and minerals, heavy metals, and microbiology parameters. And based on the 7 categorical parameters, he derived the indicator into more specific parameters, and he got 13 parameters to be prioritized for Citarum River Basin. And he did some weighting based on the expert judgment of the importance of the parameters, and also which of the parameters that's still above the threshold limit from the government guidelines. But of course, 13 parameters is still too many. We have guideline from Permen LHK or the Ministry of Environment and Forestry number 78 year 2016. There are 7 water quality parameters that need to be available to assess the river quality status in Indonesia. Those parameters are total suspended solid, use of oxygen, BOD, COD, total coliform, fecal coliform, and total phosphate. And then I will move to the conceptual framework of water quality model. I will not give you more detail about this one, but I only show you that Delta-RES has several options for water quality model. It's including the surface water quality model, models, and also water quality models on ocean boundaries. But for Citarum, of course, we only use surface water quality model. And the basis of water quality model itself, it can be from a rainfall runoff model, or the simple hydrological model, or it can be also coupled with 1D hydraulic model, or even 3D hydrodynamic model. And then we also have a process library to calculate the emission of the pollutants, the transport model, and also the water quality model. So the options is based on the availability of the data and the resolutions that we need. To get more complicated result, we need more complicated model also. And then slide, I will tell you about the development of water quality model that we've done for Citarum River Basin. So we started in 2017. We have Sobek-Delwak model for Upper Citarum River Basin under joint cooperation project. And all the activities related to the water quality model that we done for Citarum River is actually in collaboration with Pusair, water quality department from Pusair, or now we call it as Direktorat Jenderal Bina Teknik SDA. So we built Sobek-Delwak for Upper Citarum Basin in 2017 based on the existing hydraulic model by Delta-RES in 2013, and then we only use one parameter as a trial, which is E. coli, because it's quite common and the data for that parameter is available. And the source of emissions that we put in the model are from the centralized wastewater treatment plant, from communal sewerage system, from the leakage of septic tank and also from the livestock background concentrations. And we divide the sub-basin into 5 river basin, Ciwidey, Cisangkuy, Cirasea, Citarik, and Cikapundung. And this is more or less the output of the model. So we, from the model, we can see that the main source of the pollutants comes from the septic tank leakage and livestock emissions. We also applied some of management option scenario. The first scenario is the reference or baseline scenario, business as usual. You cannot change anything. And the second management option scenario is what will be happen if we do the improvement of wastewater treatment plant. And the third scenario is what will be happen if we increase the connection to the septic tank. And the fourth scenario is how will be happen if we improve the livestock management. And for the scenario itself, even though you cannot see so much differences, but we can say that the livestock management and sanitation improvement is the scenario that just quite the most. And then in 2019, we tried to introduce a new model for the water quality because based on our evaluations, the previous model, the Sobek-Dawak model, is not really user-friendly. So if you find an error, it's really hard to fix the model. And since it based on hydro, it's quite costly, hard to be validate, and it's really hard or it's really difficult to build the model from the scratch. So that's why we introduced the coupling of W-flow and emission model for Upper Citarum. Because W-flow is hydrological model, it's more simple than a hydraulic model, and Pusair itself already has the W-flow model for whole Indonesia. So you can replicate this model not only for Citarum, but also for whole Indonesia. And for the emission module, we introduced this new model for Indonesia also, because for this model, you can see the spatial distribution of the load in the catchment, and also you can see the mass balance and the degradations based on the receptors. So you can see the degradations in the paved areas, in the storm sewers, in unpaved, in surface waters, and also in soils. So this is the overview of the result that we get from the coupling of W-flow and Upper Citarum, W-flow and the emission model for Upper Citarum. So the result, we get the result per kecamatan level. The results show that the highest quality concentration contributor are from the highest population density area. And also for the nitrogen concentrations, it comes from the livestock area, which is quite low in Pasar Jambu. And also for the highest organic carbon concentrations, it's located in the main industry area, which is Majalaya. And we also already introduced our model, W-flow and the emission model, to the stakeholder of Citarum Harum project. We did the focus group discussion and the expert panel about the model. And quite settled within the stakeholders, and they might want to use it to support Citarum Harum project and quantify the water quality indicators. And then this year in 2020, we also introduced the new development of the emission. We introduced the emission new version for Upper Citarum Basin because as you can see here, the result is in catchment level, but Pusair or our partner, Indonesian partner, want to see the result also in the river segment and want to see the result not only as a load, but also in concentrations because they have the observation data in concentrations. So if we have the observation data in concentration and model output also in concentration and a river segment, it will be easier for us to do the calibrations. So the new version of the emission can calculate the pollutants as a fluxes or as a load expressed as a mass per time, and also as a concentration expressed as a mass per volume. And the new setup model contains 5 variables, which are coliform bacteria, the total nitrogen, total phosphate, total suspended solid, and also biological oxygen demand. And these are the calibration points that we use to calibrate our model in 2020. So there are 5 points, Situ Cisanti, Wangi Sagara, Koyot, Sapan, Dayakolot. The observation data comes from PUS Air staff, and they also have the data of measurement for 5 parameters that we simulate in the model, which are total nitrogen, total phosphate, BOD5, total coliform, and also total suspended solid. And then we compare this measurement data with our model output, and as well as the output of the calibrated model in 2020. Yeah, I'm quite happy with the result because the order of magnitude seems quite logic. And then besides, we also applied a simple management option scenario. We can develop it more for the management options. We applied one management option scenario. How if we increase the efficiency of the wastewater treatment plant? So the baseline scenario is the business as usual scenario. We don't change anything. And the best scenario is what will be happen if we increase the efficiency of the wastewater treatment plant. And you can see all the concentrations are decreased. And for the worst scenario, what will be happen if we decrease the efficiency of the wastewater treatment plant? And you can see that the all the concentrations of each parameters is increased. And yeah, this is the documentation of our water quality partners. So we already did some of the on-the-job training and also do the intensive training with our stakeholders to discuss more about the development or the improvement of our water quality model for Citarum River. So this is my contact, and thank you for your attentions.
Thank you, Bu Ira.
Yeah, that's all I think.
Thanks so much also for this overview of this paradigm shift. That's important what's going on, and the evolution that you show in using models for water quality study. I saw there is already a question about this in the chat, and maybe you can answer that if we have time afterwards. Also, what you mentioned might be a nice inspiration for the competition. We have now finished the lectures. We have 2 short events left on this webinar. The first one is just a quiz, just to make everybody active and involved. So the quiz is about a few questions that you all have to answer. And Ibu Tiravani, she will guide us in this quiz. There is also a prize involved, so I invite you very much to participate in this quiz. Ibu Fani, can you take over?
Thank you, Professor Elko. Hi, my name is Fani. Myself, I'm an alumni of Civil Engineering ITB for the year 2009. I'm working in Delta Res, and now I understand that it's been a long day for you. So now we try to give you a little bit of prize by following a quiz. So I'm going to share my screen now, so you can see. Now you can see, I guess, the quiz. So the quiz is rather straightforward. I think it's a multiple options quiz. It's much easier than quiz that Mahadi usually give you. So, and the first winner, we get 500,000 rupiah. The second winner, we get 300,000 rupiah. And the third winner is 200,000 rupiah. So if you listen very well during the presentation, you should be able to answer everything, and then you should win the prize. And what's really important also with this quiz, that it matters how fast you answer. So you need to, but of course it need to be correct and fast at the same time. So let's start the quiz. What you need to do, you need to use your smartphone or your browser is also fine. This is also invitation for Pak Joko or Pak Syahril or the others also. So use your phone and then go with the browsers to menti.com and then use the code 71661. After you go to menti.com, enter the code 71661 71661. Ya,
Pak Syahril nggak boleh, Pak Syahril nanti.
Ya.
Pak Syahril menang nih pasti nih.
Compete ya.
Now everyone can compete except Pak Hadi, Pak Elko, and because they know the questions. You need to be fast, but also correct at the same time. So, okay, we have 20 participants, but we have 55 in the webcam. So I expect more people to enter. 24, 25. Okay, it's getting up. There is no reduction in your score in the GPA if you lost, so you should just enter.
Marino join.
Yeah, Pak Rino should join also.
Sip. Kalau menang traktir Pak Rino ya.
Okay, we have 33. It's still going up.
Yeah.
35.
So I
okay.
PhD students, master students.
Yeah. 40. Okay. I think we can start. So this is just well, for the started of the questions. So just write your email address because now we know how to contact you if you win. Okay. Well, we see more people. Okay. I have everyone ready. Wow, we have more people.
48, no?
Yeah.
More than 50%.
Yeah. I think people are still answering, so it's cannot move. Let me. Oh, it's okay. Now, are you ready? First questions. Sorry, the first question, okay, it takes a bit slow. I think the connection with the internet. Enter. Something is. Okay, I'm not sure what's happening.
Nobody win. Nobody win.
Sorry, I think it's too many people coming in.
Yeah, maybe it's a little bit delay, I think.
Yeah, it's a little bit delay. Okay, now it works because now I think everyone now look at your phone. What is the biggest reservoir in Citarum in terms of volume? You can Google, but then you will lose time and you cannot win. So 8, 7, We'll see. Time's up. Oh, okay. So most of you correct. So yeah, Jatiluhur is the biggest reservoir in Citarum. Let's go to the next one. Okay, let's see who is the.
Yeah, it's.
Okay, Salma is the fastest. Okay, congratulations for Salma. This is only the first question. You need to keep up with Salma. Let's go to the next one. Question 2. Yeah, I will start. So you need to answer fast to get more points. What is the biggest problem of Citarum? So these people should know after listening to the presentation, is it water quality, flooding, or both are equally important? So answer fast. 5, 4, 3, 2, 1. Yeah, the correct answer is, as you know, the presentation from Professor Matthijs and also from Bu Ira, both are equally important. Now let's see. Where's the top? Okay. Oh, Jonathan is very fast. Okay. Let's go to the next question. This is the third question. So be ready. What is the most severe flooding problems where are in Citarum? Be careful. This is a bit of tricky questions. 5, 4, 3, 2, 1. Very good. Okay, so I think most of the ITB students are actually giving the correct answer. This is a very good start. Well, Jakarta is not in Citarum. Let's go to the next questions and see first who is the winner now. Oh, Jonathan is very fast. Still on the top. Okay, let's go to the next one. Question 4. What is the main cause of flooding problem in the Bandung Plain? Is it climate change, soil subsidence, or deforestation? Oh, it's unfortunately the main problem is deforestation. So this is the last questions. And let's see who is on the top. Okay, seems like Jonathan leads very high, and then there is Thibaut and Aaron after. So this is the last question. This will be the final. And you will know soon whether you get the prize or not. What is W flow model? Is a model from Deltares. Yeah. 7, 6, 5, 4. Okay, the correct answer is hydrological model. So it transfers the rainfall into discharge. Very good. Now let's see who is the winner. Let's see who is the top 3. Okay, Jonathan, congratulations to win. So maybe Jonathan, you can you can present yourself for 30 seconds just to introduce yourself, and congratulations for winning. And we'll also give the prize for the second and for the third. So Bapak Jonathan, Do you want to speak a bit? You are winning the quiz. Or maybe you are muted, maybe, I'm not sure. Okay, but okay. Yeah, Pak Jonathan?
Good afternoon from Indonesia. Thank you for the opportunity in this quiz. I think we can have a better opportunity in the next event, and for greater relationship between Indonesia and Netherlands itself. Thank you.
Thank you so much. Okay, this is the end of the quiz, and Pak Jonathan, we will contact you for the gift. And so this is the end of my session. So I will return this back to Professor Elko. Thank you. I hope you enjoyed this.
Thank you, very funny, and congratulations, Jonathan, and the second and the third prize winners. It was just for fun. The serious things is coming now, and that is the start of the competition. I will share my screen now. This competition will be introduced by Koos Wiedix. Koos is in the ministry. Koos, are you still there? Because you had some other obligations. Are you still online?
I'm still online, and I'm enjoying the show.
Okay, so if you tell me when I have to go to the next slide, tell me. But I give the word to you now.
Thank you very much, Elko. I must confess, I just lost all my credibility as somebody speaking about the Citarum River. I ended 27 in the quiz, so I hope people will still believe what I'm saying. I'm a Dutchman working at the Ministry of Public Works in Jakarta, PUPR. I'm involved in the NCICD Jakarta Bay project. And now that's about the fastest sinking city in the world. It's quite special now to talk about a river that has the reputation of being the dirtiest river of the world. Those are reputations, I think, Indonesia should quickly change, and I hope we can contribute to that a little bit. On this picture, you see two publications. There were the Rotten River that was in the Guardian last week, and the Jakarta Post some time ago wrote about also about the Citarum and the Citarum Harum project. But unfortunately, COVID is also disrupting that. So what I want to do is give an introduction to the competition we have organized. You already received a lot of inspiration, I think, by all the speakers that have given their presentations. They all had a quite different approach. From my side, I want to add a little bit more. I used to be a long time ago the head of the International Rhine River Commission in Europe, and this river went through all the stages that the Citarum will also go through: quality problems, ecological problems, flood problems, and at the moment even drought problems. And they were tackled step by step, and sometimes they needed a big push because of a disaster in Switzerland a long time ago, because of flood problems in '93 and 1995, and also big steps were made suddenly by all the attention that was given to the problems. And that's one issue. Public awareness is very important in dealing with river problems. Second thing is, in the Rhine, we learned that you can make very, very big steps forward by prevention. You can try to clean your river now. That's quite a challenge. But in the Rhine, we after 1986, after the big disaster where all the life was killed, the policymakers said, the politicians said, we are going to reduce the pollution load by 50%. And keep that in mind. Everything you don't dump into your river, you don't need to clean up afterwards. And that's sort of easy solutions that also could be used in the Citarum. Now, going to this competition, we invite students. Individual is in this slide, but I understood that also groups of 2 are allowed. And yeah, the simple assignment is come up with an innovative idea how to solve the flooding problems or the water quality problems or both in the Citarum River. And all your solutions are valuable. Solutions for floods, for quality, solutions at the source, solutions at the end of the pipe, technical solutions, managerial solutions, economic solutions, legal, ecological. You heard about nature-based solutions. Everything is allowed, and write down your solution. And maybe Eelco, you can move to the next slides now. You have to submit an abstract of 200 words, and there needs to be a backup of maximum 10 slides for explaining your idea, your vision, and your innovative solutions. 200 words, 10 slides, and you can submit them to an address that is given here. This link brings you to a beautiful website, and there you find further instructions how to submit your contribution. We have to move back again. Sorry for the illogical order of these slides. The time frame for coming up with your solution is please make a registration. Tell us that you are going to participate by November 9 at the latest. Then send your abstract and your slides before November 25. And then we have the opportunity to look at the contributions. And then in the next session we will have, and let's move back to the next slide again, Eelco. In the final session, the top 3 will be asked to present their ideas in the next webinar, and that will be on December the 3rd. We have a sort of jury evaluating all the assignments that we receive. That will be Dr. Hadi Cardana, that will be Professor Eelco van Beek, Dr. Rino, and I myself will be happy to look too. And we use the following criteria: originality, effectiveness, efficiency, implementability, sustainability, and the way you present it. For the best 3, we have prizes, nice prizes, 10 million, 7.5 million, and 5 million. And now that should also stimulate you. But I think what even more would stimulate you is that you, with your contribution, can maybe add to the solution of the problems in the Citarum area. So far, Ilko. Thank you.
Okay. Thank you, Koos. This is clear, I guess. Important is that you register before Monday, and you can do that through the website that you just saw. That's also the website that you use to register for this webinar. The central point for this competition is Pahadi. Pahadi, would you like to add something to this? Pahadi?
Maybe Pak Sahril.
Of Professor Shahril, yes?
So
Otherwise,
I think Paris is more proper because you arrange the. You mean about this competition or?
yes, about the competition indeed. So if the students have questions, they can approach Pahadi for the details, and maybe you too.
Yeah, so I think all the students or someone that interested to join the competition could contact us in this case, yeah?
Yeah, okay. Good, so because there might be questions. So maybe I would like to conclude now the session. We are running over time already a little bit. The question that have been asked in the chat box. Yes, Pahadi is back. Pahadi, would you like to add something to the presentation that Koos has been given?
Pahadi.
Okay, tidak apa-apa.
Sorry.
So the important message is that if there are questions from the students, that they can approach you, Professor Shahril, and Pahadi for these questions. Yes.
I can arrange that. Okay.
Yeah. Okay. Now, thanks very much. Because given the time also, and we have been running over time, I want to conclude it. The questions that have been asked in the chat box, they are being answered by the presenters, and we will go over them also later to see if there would be a follow-up. And please free to reach us anytime if you have questions on the presentations or on any way that we as BTHF can contribute to it. I would like to thank everybody, the staff of ITB, also Pak Bob, he left already, for the presentation. I would like to thank also the presenters for their contributions. I really hope this webinar is useful. It is very much liked by us to be in touch with ITB, and so we will be back. We will be back in a few weeks, and there will be information about that with the presentations of the selected winners, and so the prizes that will be awarded. So we will see each other again. But for now, I would like to conclude again by thanking everybody to participate. I would like to give a last word to Professor Joko and Professor Shahril to close this meeting. Professor Shahril, you're on screen, yes?
Okay, thank you, Mr. Eko. So I'm very happy and honored to continuing attend these events, and I hope that this event not for the last event. I think we look forward to the future to see potential cooperation event something like this, maybe more than that, in research corporations, in project corporations, also maybe if a possible exchange of the ITB staff and Delft staff, and also with Delta Res in this case. So I think this is my, close remark from this events. I hope that all of you stay safe, yeah, during the pandemics, to to look forward for future cooperation works. Okay, thank you.
Okay, thank you for Professor Cyril. Professor Joko, are you still online?
Yeah, I think. Joko, I think you are mute.
Yes, still mute?
Okay, thank you.
Okay. Okay, so thank you very much for everybody who's attending this webinar, and also thank you for all the speakers, Professor Matthias Kok, Ibu Ira, and Pak Hadi Kardana. So, and also thank you for all the BTHF and Delta Res teams, Pak Elko, Pak Kus, Pak Fritz, Bu Fani, and I think I mentioned everybody, right? So thank you very much. So hopefully we can meet again in the 3rd of December. So Pak Rino will be the person in charge for this occasion. Thank you very much and stay safe. Have a good evening for everybody in Indonesia, and have a good lunch in the Netherlands. And bye-bye.
Okay. Thank you, Pak Joko. Thank you, everybody. We will meet again. Bye-bye.
Bye.
Bye, everybody.
Stay safe.
See you next.